All right, let's start playing around with polar. Let's plot some points, and then we'll move on from points and we'll start talking about equations. So what I have here is just a little xy. Wrote a list of our points we're going to want to plot. But let's have a quick conversation about this. There's terms we have to know. The positive x-axis is what we call the polar axis. We can think of this as where we start. This is like our origin, essentially. Instead of x's and y's, this is where the angle equals 0, or 2 pi. So for example, we could have a point 1 comma 0. And let's say it's 1 unit, we'd say it's this long. Or we could say 1 comma 2 pi. Go around in a circle and we're still at the same gosh darn point. Or we could call it 1 comma 4 pi. Go around in another circle. We end up back at the same spot. Shoot, we could call it 1 comma negative 2 pi. Or we go back around the other way. You remember trig, don't you? A little bit of it. Cool. So that's going to be kind of our game. So let's plot a few of these. Let's plot some points. Now we have a positive direction, right? But you know that from the unit circle. It also helps out that you get quadrant 1, quadrant 2, quadrant 3, and quadrant 4. That might be the reason why they're numbered that way. I have no idea, just assume it is. I say a lot of things. Don't believe anything I say. Make me prove it. All right, let's go. So let's take our first one, 1 comma pi over 2. Get rid of all this because we're not there any longer. Whatever. I'm going to call this 1, 2, 3. 1, 2, 3. They're all positive now. You see that they're all positive? Because we're just talking about the radius is just the distance from the origin. So we go to our first point. It says go to pi over 2, 1 comma pi over 2. But I always read it as the angle first. And then we're like, okay, go up 1 unit. 1 comma pi over 2. Sweet. We graphed a point. But it's always nice to draw the line. So that's how we go in the positive direction. Now what's up when we go to 2 comma negative pi over 3? Well, we got to move the other direction. We got to go down, right? Down like this to where the angle is negative pi over 3, right? But we only want it to be 2 units long. So let's kind of approximate it. Be like, that's about 2 units. So there's our point. We can say that this point is at 2 comma negative pi over 3. Right. Just plotting some points. You'll have that in your homework. That'll be the mellow part. You're like, just plot some points. Let's get it down. And then lastly, let's deal with this one. Oh my goodness, is that a negative radius? I thought radii were always positive. Well, they typically are, unless we're in polar, because this gives us the ability to make loops. Probably won't make too much sense yet. So let me draw it out the wrong way first. Use a different color. I want to find pi over 4. There you go, this angle, pi over 4. And let's make this 3 units away. So we say this is positive 3, comma pi over 4. Now, what do you think is going to happen? Just to make a guess in your head, what do you think is going to happen with a negative radius? I'll bet you're right. Yeah, it flips. It goes the other frickin' direction. So what you'll do if you want to plot negative 3 comma pi over 4, graph 3 comma pi over 4, and then flip it. Make it go the other direction. And we can say that this is negative 3 comma pi over 4. But this angle here is actually, do you know that angle? Do you know that angle? It's 5 pi over 4. These are actually the same things. It's kind of funky. It's kind of weird. So let's write in our formulas now, because we have a rule about all of this. So let's write some points. So we could say the point, the radius, and a theta. Now you could add any 2 pi you want to this. Shoot, we can add any 2 pi k. And this would be the same thing as not adding it, right? Because no matter how many times we go around in a circle, we end up back at the same spot. It doesn't matter. Now here's the next one. Now if you have a negative radius, oh geez, what's that going to equal? Well, this is going to be a point. You can change it into a positive. And then you can either add or subtract. Doesn't make any difference to me. Pi. 180 degrees. Didn't we move 180 degrees from here to here? Didn't we just go the opposite direction? Yes, 180 degrees is pi. So this will get us our other points. This allows us, it doesn't seem like it now, but that little but I showed you before, notice I had that little inner loop. It's how we're going to create them once we start to graph. So let's do one more thing, and let's just plot a couple more points. Let's plot this point. This point, I don't know, let's call it 2 comma, and let's make it 9 pi over 4. And then let's do another point, and let's call that 2 comma pi over 4. And then I'm just thinking, let's do one more. Let's call this one -2, but let's call it 5 pi over 4. Let's see if we can't sketch that one out really quick. And then we'll move on to some equations. But we got to get a solid foundation before we move on. Hopefully this is review, and you don't have to go through learning something new in calc while doing calc. So let's go to our first one. 9 pi over 4. Now, do you know the little trick with stuff like, you're like, where does it go? Well, I want to change 2 pi into 8 pi over 4. See that little trick? You just multiply by 4 top and bottom. Isn't 8 divided by 4 equal to 2? Therefore, 9 pi over 4, let's go around all the way in a circle, and we got to go one more. And we can call this 2 comma 9 pi over 4. All right, we just had to go around in a circle, 8 pi over 4, 2 pi. And then we had to add another pi over 4. So there's our point. Okay, cool. Now let's do 2 comma pi over 4. Oh, they're the same point. Shoot, I'm sorry. I guess I gave you the same point. Oh well. Okay, let's go deal with our last one. -2 comma 5 pi over 4. So let's get the 5 pi over 4. Go around to here, and we're like, oh, there it is. There's +2 comma 5 pi over 4. But we want to just kind of sketch that first, to get that 5 pi over 4 all the way around. So then we can do our p, so which means, oh yeah, we just flip back the other direction, and these are all the same point. You can see by using that new formula, it tells us that if we change this to a positive, all we got to do is add or subtract pi, or 4 pi over 4. So this is the same as 2 comma pi over 4. Maybe if we added pi to that, it'd be 2 comma 9 pi over 4. So they're the same values. This is our game with points. We're not going to do a lot of stuff with points as far as what you do further in the class, but if you don't understand the points, how the heck are you supposed to get the equations? Could you imagine trying to do like algebra, but you just didn't know your x's and y's? You're like, I don't know what that means. And then I was like, okay, cool, go graph a parabola. You'd be like, I don't know what that means. Same sort of game. So while this isn't used all that much, it's needed to be able to do more. All right, I'm babbling. I'll shut up. We'll come back and we'll do some equations.